Good morning. This is just a quick walkthrough of the notes for hypothesis testing for one proportion. This is for my quarantined and absent students. So this isn't like a lot of my other notes videos. I'm just going to walk you through the key to the notes and kind of point out a couple of things here. So in the first part of the notes, you're going to see that there's a link to this video about smelling Parkinson's disease. So there's also a link in the Schoology folder for that. And I'd recommend that everybody watch that. So if you haven't watched that, just stop. It's like 2 or 3 minutes and watch that video. Okay, so this video is about Joy Milne, and Joy believes that she can smell Parkinson's disease, and so they decide to set up a test for that. And a couple of things that we want to think about is why would it be important if someone could smell Parkinson's disease? Like in this case, and if you're watching the video, they talk about early diagnostics and being able to use the idea of a chemical change in the body to help out. And then we want to know, well, if she was just guessing. So what they did was they gave each person 12 shirts. Sorry, they took 12 shirts. They had 6 people who had Parkinson's disease wear these shirts, and they had 6 people who didn't have Parkinson's disease wear the shirts. And then they put them each in a plastic bag, and they gave them to Joy in a random order. And she had to guess whether or not the person had Parkinson's disease or not. So what we want to think about is if she was just guessing, because it's logical to be skeptical of claims that are different from what you would believe, and they've never met anybody who's claimed that they could smell Parkinson's before, we would expect her to get about 50% of those right. So correct decisions out of 12, how many would you get if you were just guessing? Probably about 6, right? You have 50-50 shot of guessing correctly. So we would expect her to get about 6 correct. So how many correct decisions would it take to convince you that she can actually smell something? So you have to think about it. Well, what if she got 7? Okay, that's a little bit more. But is that enough to convince you she didn't just guess? Could you get 7 just by guessing? What about 8? Or 9 or 10? At what point does it become unlikely that she's just guessing? And so in the video, it talks about how she actually guessed 11 correctly. And the one that she got wrong was a person that she thought had Parkinson's disease. And the doctor said, no, this person doesn't have Parkinson's disease. And come to find out, that person actually went on later to be diagnosed with Parkinson's disease. So she was actually able to sniff it out before there were any other symptoms available to them. So we're going to use this as kind of the backdrop for our hypothesis testing and for this vocabulary. All right, so there is this idea of a formal test of significance. These are sometimes called hypothesis tests. And what we're trying to do is we're trying to come up with this idea of how strong of a sample do we need? How small of a chance does it need to be to convince us that our original claim is not true? Okay, so we're going to start off with some vocabulary, and our vocabulary here is null hypothesis and alternate hypothesis. Okay, so the null hypothesis is the situation that is assumed to be correct unless evidence suggests otherwise. So in our case, because we'd have no reason to believe that anyone can actually smell Parkinson's, this isn't something that we would think it could happen. Our null hypothesis in just words is that Joy is just guessing. Joy is just guessing here. Because at this point, we don't believe that people can smell Parkinson's. Our alternative hypothesis or alternate hypothesis here is a situation for which we're trying to collect data for. So in our case here, the alternative hypothesis is that she's not guessing. She actually can smell Parkinson's disease. So in words, and this is what we're looking for evidence for, which is why they set up the test with the t-shirts. Okay, so if we were going to set this up in symbols then. For the null hypothesis, what we want is we're going to be talking about a single proportion in here. We have this symbol HO, and it's there's a little colon after it, okay? And then it says P equals PO, where PO is the hypothesized value for the population proportion. So if we're saying that P is the proportion of correctly identified shirts, and talking about a future, like if she was going to do 100 shirts or 1,000 shirts in the future, how many would we expect her to be able to do? So we said 6 out of 12, which is 50% is what we would expect. So let's write that as a proportion. So if Joy is just guessing, the null hypothesis would be that P equals 50%. Now, our alternate hypothesis can take one of 3 forms. We usually say HA for alternate hypotheses. Some people will show it in textbooks as an H sub 1. Okay, so sometimes you might see that. And it's either going to be a less than, a greater than, or a not equal to. So you have to stop here and ask yourself, if Joy wasn't just guessing, if she really could smell something, do we think that she would get less than 50% correct, more than 50% correct, or do we think it will be different either way? And in this case, if we we would expect her, if she really could do this, to get more. All right, so our alternate hypothesis, notice it looks exactly the same as the null hypothesis, except for we have an HA instead of an HO. And in addition to this, we have the equals and the greater than, and the 50% is the same, okay? Now, our question is, how likely is it to get 11 out of 12 correct? That was what Joy actually got. Like, what is that probability? If she's just guessing, like, how much is this likely? Could you just get guessing? Because I feel like I could probably get 7 out of 12 by guessing, or 8 out of 12 guessing, maybe even 10 out of 12. But she got 11, and she actually got 12. Like, could that just have happened by guessing? Like, does this convince us that she really can smell anything? So what we did in class is we ran a little simulation with this, and we did this with cards. And I'm going to pause the video really quick, and I'm going to go over and grab the poster that we made yesterday in class. All right, now I realize that my video is backwards, so you're going to have to bear with your old teacher here who doesn't know how to fix that yet, but I'll fix that for next time. All right, so one thing you'll notice is that this is the one we did in class, and you can see that there were a lot of 6s, okay, and some 8s, and even quite a few 10s. But look how many people got 11 and 12. Not anybody. All right. So, we in our class, what proportion of simulations had a result that was 11 out of 12 or larger? Nobody. 0. Okay. But we only did like 50 trials because I had everybody in one class do it twice. So I only had like 50 trials. So what if we did this a bunch of times? So I went online and I found a simulator that would do the exact same thing we did in class. And I had it run this 100,000 times. And then I had it calculate the percentage of dots that were greater than or equal to 11. And it said 0.3% of the dots were in that specified region. Okay, so that is 0.003 here. 0.003. So the idea is, what is that probability then? What is the probability? What is the probability of getting 11 out of 12 or more? This is probably pretty accurate. So if that null hypothesis is true, it's about a 0.003 chance. Now, we call this the p-value. Okay, so the p-value is the probability of getting a result like ours or more extreme. So getting 11 out of 12 or more correct, assuming that the null hypothesis is true. And in our case, that would be assuming that Joy is just guessing. And she really does have a 50-50 shot because she's just guessing. Now, we've been doing this all semester. So, and all year, actually, even on the first day of class, we talked about the sexual discrimination problem. And we said there was about a 16% chance of them firing 5 or more women out of this. So, when we're talking about these probabilities, we're making an assumption at the beginning and then calculating this. Anytime you've been asked to answer the question, is it an unusual result? You've been basically doing this based on our assumption. How likely would it to be to occur? All right, so is it possible that Joy correctly identified 12 shirts just by guessing? Absolutely, it's possible. 0.003 of those 100,000 trials show this result. So it's possible. Okay, another way to think about this is that if I put 3 slips of paper that have a dot on them in a bin, and that bin has 1,000 identical pieces of paper, it's possible to pull out one of the dots, but it's not very likely. So this is a really small chance of happening. And so we say, it's like, no way. Like, if Joy is just guessing, it's extremely unlikely for her to get 11 out of 12 by more or more guesses correct. So what this does is this convinces me. Like, I know I'm not 100% sure here, but there's a very small chance that she got this by guessing. But I think this is strong enough evidence that she can actually smell Parkinson's disease. Okay? All right, so we're going to use this as the backdrop for running a hypothesis test. Now, I'm going to stop this video, and then I'm going to make a new one. So that's just that beginning, that intro. So make sure if you have missed class, you're going to watch this next one as well.